Hello to everybody. So today, the topic we have called Innovate at Scale with Enterprise Configuration. And what I would like to spend the next 25 minutes around is some of the key features that we believe are essential to be able to roll out an enterprise configuration solution so that it becomes an efficient tool to support innovation. And of course, you can ask yourself, what does innovation mean, and what do we mean by innovation at scale? And some of the key aspects that we have found are important is some of the things listed here. We are talking about being able to quickly try things out, iteratively collaborate, analyze what happens if we do this and that, what would the cost implications be, and also having an outside and in perspective where it is more a top-down from sales driving engineering rather than from engineering dictating to sales and marketing what to position in the market. So I'll try to cover some of these areas in the next minutes. And before I do so, I want to refer back to the webinar we had a couple of weeks ago, which you can access on our website. And that was really a broader view where we argued for how product models are the core at enabling an end-to-end enterprise configuration solution that links engineering, sales, and service and manufacturing. And the key element in getting these different functional areas linked in an organization is that they share the features of the product, so that these features become the key language we say in how you talk about the variability of a product. So not so much the parts themselves and the individual part numbers, but more that the capabilities of the product. And in the center of this, you have the modeling aspect, and that's what we're going to zoom into today and look at in a little bit more detail. What is it that sits there in the middle, and how do we manage these models that are to be put in place so that engineering and sales and manufacturing service are all aligned on the products that an organization is offering to the market. So at the center, we have what we call product models. Product models deals with features. That's the level that they talk about variability. And once you have defined the features, you can then start breaking that into more technical aspects, such as the bill of material definition. Those aspects are sitting outside of the product models. They typically live in a PLM system. That's where they get managed and evolves, and that's where engineers are working with the parts and the bill of materials. But the variability of the product is defined in the product model. And when we talk about modeling, it is basically about defining the features of a product. It's fundamentally rather simple. On top of that, we often have a number of rules. The rules are controlling relationship between the features. They define, you could say, the variability that we would offer. Some of these features are going to be highly technical. Others are going to be much more market oriented. They all go inside the same product model. And from that perspective, you could say that the modeling is a fairly simple thing. You can almost say we could create these product models in Notepad or in any way. It from that perspective, it doesn't require a lot. And there are many tools out there on the market that can do this part. So what I'm going to talk about today is those things that go beyond and what will be important the moment you go from having a single person or a few people that define these models and go into a larger enterprise where you have to have collaboration going between different parts of the organization, different engineering teams and sales and marketing teams. and start to really roll this into a large organization. So I'm going to talk about 5 areas, and these are the ones that I would like to spend a bit of time on today. The first area is that of versioning, and talking about how we can version and work with different versions of these models. If the configuration system cannot deal with different versions, then you're already there set up for a lot of trouble. And other capability that we find and we need to offer in an enterprise modeling environment is a support for effectivity. Effectivity is a well-known concept in automotive. It's not so well known in other manufacturing companies, but it is getting there, and we strongly believe that that's a key element to be able to work with these models in an efficient way. Then I'm going to talk a little bit about these different perspectives between engineering and marketing. Those are the typical 2 main views, but there can also be other views coming from service and manufacturing. Then I'm going to talk a little bit about validation and analysis, how important that is. And finally, I'm going to talk about security. So those are the 5 areas that I'm going to cover in the next 20 minutes, and which we believe in Configurable is quite essential to be able to work with these models in an efficient way. So let's look up on versioning. So the ability to version is, of course, a standard thing. It exists in many different flavors. It's done in one way in PLM and ERP systems, which we call local versioning, where each data item goes through its own life cycle. In software, there's another concept of versioning, which is more what we call a global versioning concept, where you work with branches, and this is a way to work with a collection of data items that all have to be in alignment. And this concept that is well known in the way you develop software, we have carried over in the work that we do in configuration management, and we call that work items. And the idea is that when you look at the models that you develop, they live in a master branch, and whenever you have to modify the data in the master branch, you create a work item. And in creating a work item, you basically get we don't actually copy the whole database, but it looks like you get your own copy of everything in the database. So you don't version each individual rule, you version everything in the database as a separate thing. And once you do that, you do your work, and once you've done that, you have done all the work in isolation from everybody else working on the data. Once you've done that, you test it, and at the point where you are ready to and have tested it thoroughly, you promote it back in master, and the changes that have been done in the work item are carried over to the data that sits in the master. So that's just a very different versioning model, and one that we believe is much superior to the traditional versioning model that's found in ERP and PLM systems. The way you work with this supports collaboration extremely well, because you can have many different work items and teams working on different work items at the same time. Here is a highlight where you can see the master branch gets, there's a work item, a green one being created from this version of the master, and there's a purple one at this point, and then the green one gets promoted, and later the purple one gets promoted, and the master gets sort of updated with the combined effect of the two. At any point in time, you can update what's in the work item. That's illustrated in the red one down here, how you can see the data gets updated in the red and brought in, and still in isolation. You can test that the changes in the red work item still is okay, based even though the green and the purple is being brought in. And once you have tested and validated the updates that are done, the changes that are done in the work item, they get promoted. And of course, what can happen, and that's also a well-known concept in software, is that you might accidentally have 2 work items that modify the same data set, And in that case, there will be a conflict when you merge them together, and that conflict will have to be handled, and you have to have some tools to support that. The ability to have a strong versioning software allows you to trace very efficiently. I'm trying to illustrate this with a simple example. So you can imagine that you discover a problem in the manufacturing. So this, of course, would be a very late to discover a problem, and hopefully you have discovered a problem before that. But this actually does happen in practice, that you people who are gonna manufacture the product discovers that this doesn't work. There's a hole in the roof for the sunroof, but there's no switch for it or whatever. There's no wire harnessing for it. Now that error is of course caused by a problem in the bill of material, and that bill of material was driven from a particular configuration. So the first step would be to track and know what configuration was used to produce the bill of material that was causing the problem. Now, a key element there is that you need to track the version of that particular configuration. You need to know when was the effectivity date for it and what was the version for it. Once you know the version of this configuration, knowing that the rules that was used to create this configuration had version 42, you can go back and you have the full history of all the changes in the master branch, and you can find out that version 42, say, that might have been the one that was exactly at this green point here. And you can find out what work item was it that introduced that particular version, and that was this green work item here. And once you have that information, you can trace all the way back to the work item, and the work item will tell you who and what and why and when did a change be introduced. And it might even contain a linkage all the way back to the change process in a PLM system. So this, of course, is the way that now you can open up this work item. You can look at the rules as they were at the point in time. It might have been 6 months ago. You can analyze the problem. You can fix the problem, and you can take that change, and if it's still present in the current rule set, then you can bring that change forward to the current date and get that change released out. Being able to do this type of traceability is, of course, quite essential in order to be able to track all the way back. And this also goes when you talk about install base and want to upgrade a machine, for example, that was manufactured 3 years ago, and now you want to service it or upgrade it. You need to have this type of traceability to all the way back to what was the rules that created the configuration back in time. So this leads naturally to the next concept, which is closely related, and that is that of effectivity. When we talk about effectivity, it's very we typically talk about it as date effectivity. There are other types of effectivity out there, but the date effectivity allows you to specify for features, options, and rules the time interval where that information is valid. So it's a mechanism that allows you in the configuration system to specify information that comes out in the future. So you can already today put in a rule that doesn't apply until, say, a year from now, and you can test and validate that the effect of that rule is as you desire. And you can do that today and don't have to wait a year to put it in. That's a very efficient and very effective way to work with the model data. It also allows you to support a continuous evolutions of these models, because you don't have to have this year's model and then create a copy of that for next year's model. You can have one model where the changes are just continuously being introduced over time. In a way, you could say that effectivity is also a way to do versioning. You could say that the new version of the product comes out tomorrow, which is different from today. But these two concepts are actually, in a sense, orthogonal to each other. And this is, you can try to illustrate that this way, that you might have a rule. It says that in the US, you must have a reverse camera, and that rule has some time effectivity range that it applies, that it doesn't apply until a certain point in time. Now that rule might be in version 1, and we can then modify it, and that will give us a new version. Now the new version we can tell is only changed in the effectivity. So we basically push the time where this rule starts taking effect. We push that out in time, and that gives us a new version. And we can also change the rule and keep the effectivity, and that will create a third version. The whole point here is that the versioning and the effectivity concepts are two separate concepts, and they go hand in hand, and they are both essential to manage the change over time. Third area that we see as important is to have a way to separate the different intents of the rules, and the typical way to split this is between the engineering intent. Engineering rules are technical rules. They typically talk about the technical aspects of the product, and they are put in place to make sure that the product will work correctly, will be legal. And then on top of the technical rules, there's a separate set of rules that are the marketing rules. The marketing rules deals with how the product is being positioned in the different markets. And also the marketing rules typically adds more commercial aspects and more maybe customer requirements and needs, and link those to the technical aspects of the product. Those are two very different views, and the way you work with the rules and the way you analyze the rules are different in these two domains. You want to be able to understand the consequence, for example, of a change, whether it's going to affect only the marketing rules or whether it also is going to affect the engineering rules. There's also going to be different editors. In the lower right hand corner is a screenshot from our ACE application of how a commercial perspective looks like. This is also a rule editor, but it's structured much more rigorously in a sense, and it's a way for marketing to specify how is the offering in a particular market at a particular point in time, what features are standards, which ones are optionals, and that kind of thing. But it's also a rule, and you could technically have written it as a much more low-level rule as the one shown on the left. Fourth area, validation and analysis. Once you have created these models, it is of course important that you can test them. And I think the test and validation aspect has often been neglected. It is not sufficient that you can run a configuration session. Just imagine that you have 100 different markets, that's not uncommon, and have to test a change across 100 markets. That there's no way you can test that manually by going in and select the market and see that the configurator behaves correctly. You have to have tooling that helps the modelers, the people who manage these rules, understand the consequence of a change. You have to have tools that automatically, every time you do a change, you just push a button and it will run through a sequence of automated tests to validate that nothing has been broken by the change that has been introduced. And this again is also quite standard in software. You have unit tests and integration tests, and those tests you always run whenever you do a change. You run all the tests, and they may bring up an error, and you would have to dig into it and understand why some of the tests have changed, have failed. Of course, it may be that the tests have to be updated, or it may be that you have introduced an error by mistake. Having this tooling as part of the modeling environment is quite essential to be able to efficiently roll out changes in the organization, and keeping this comfort that you have not broken something when you do a change. Another area in this space is, of course, to start doing analysis. And this is when we talk about innovation and understanding the consequences, this is quite essential. And one of the areas that is quite interesting, of course, is to understand if you introduce a new feature, what's the effect, for example, on the bill of material. Here's shown an example where you have a part of a steering wheel, the switches behind the steering wheel, and there are different drivers that drives the variability. And in this example, apparently there's 96 different variations based on the variance drivers that controls this particular part. And of course, you can ask yourself, why is 96 the right answer? Why do we really need that many? What is it that drives that variability? And can we find a way to simplify and optimize that and reduce that complexity? And you can just see if adding another feature to this this particular part of the vehicle, then that number might quickly go up to a much bigger number. You might have to introduce another 40 or 80 parts just because you introduce a single new feature. So being able to do this type of analysis, that goes hand in hand in the validation. Once you have your model, you can run reports, you can run analysis that will help you understand the changes that you are introducing. So the last area I want to touch upon here is security, and again, this is an area. It's not a very hot area, but it's quite important. You need to make sure that the data that is being put into a configuration modeling system is secure. This is typically where new features start their life. If you do any kind of model-based systems engineering, this is where you would start. And this information, of course, is quite essential to have under control. You need to know, for example, who may see what features even exist or certainly exist on a certain product. That information can be quite sensitive. You may also need to have control over who can edit these models. And since they go downstream and affect maybe websites and ordering portals and whatnot, it's not everybody who can do this. Same thing with approving changes to a product model and releasing a change out to the downstream systems. Each of these require different roles, different permissions, and you have to be able to control all of this. Also, of course, we might be able to export the data. And there are many more areas that needs to be managed from a security perspective. So that was what I had to talk about today. Very quickly, I was going through these 5 areas. And this is over the years certainly been the areas where we found that it's quite essential in large organizations where you have multiple people collaborating and working with these data. So with that, I want to try to have some time for answering questions. We still have some time this time. So and I can see there's already a few questions coming up here. Let's see here. So first question is, what ERP systems do you integrate with? Well, we have a very strong collaboration and integration with SAP. That's been the most predominant ERP system that we work with. But we are, I would say, fairly open to work with other ERP systems. We have over the years done integrations to many types of ERP systems like Barn and Oracle and others. But I think the concepts will stay the same. Of course, the ERP system will have to be able to deal with what's called super bombs or 150% bombs. Otherwise, it's a bigger challenge. Can non-technical people write rules is a question, and I would say both yes and no. I think rule writing is not a simple thing, and understanding the effect of why the rules behave in a certain way, that requires some pretty strong skills in reasoning and logic and those areas. But we strongly believe that the way to write the rules should be in the most natural way, so you don't. So we need to be able to write the rules so that the product experts, the people who knows about the products, they can understand and validate them. So I would say you have to have technical people to write the rules and manage the rules, but you need also to have a system that supports rule writing in a form that can be communicated, and therefore maybe and often we build specialized editors, for example, to support a special way to create these rules. Another question is, today the rules are in PLM, ERP, and other systems, and yes, that is quite common that the rules are basically distributed among different enterprise systems. What experience have configured to transfer my current situation to an enterprise configuration architecture? So should modelers better come from sales or better from engineering department? There are many questions here. Let me take them one by one. Yeah, so rules start in many places, and we have a lot of experience in this. There are different approaches. One is, of course, to keep them in whatever legacy system you have and just continuously feed them into a centralized place. That's something we do quite often, where we, for example, get the engineering rules from one system, and then we put a layer of marketing rules on top of that. We analyze the combined effect and feed the downstream systems from that. We have also examples where we basically take over the rule authoring and keep only, for example, in SAP, move the rules out of SAP into our solution, but keep the what's called the KMATs in SAP, but without the rules. So that's another way of doing it. But certainly we can convert once, or we can continuously load. I'm just reading through here. Should the modelers better come from sales or better from engineering? That's a good question. I think the people who do the modeling, they sit between the two organizations, and as I said, they do need to understand both sides. Most often they sit organizationally as part of engineering, but they do need to deal with both, and I wouldn't say one is better than the other. They need to understand both sides equally well. What are our experience with a shared collaborative modeling with many people in contrast to centralized modeling of less people? Yeah, so very often these, it is a centralized group of people who are managing the rules. That group can still have 5, 10, 15 people. They do need to collaborate, and one way to do that is export data sets out of the configuration solution and feed it as, for example, Excel to engineers, get that information back, validate it or update it, and then load that into the configuration system as an update to the rules. And that will be orchestrated by these people sitting in the rule management section. There's a lot of questions here. How to manage configurable vehicle code and connected configuration. I'm not sure I understand that question. How to manage configured vehicle codes and connected configuration. Yeah, I'm sorry, I'm not familiar with that term. There is a connected configuration. Is that related to connected vehicles? I'm sorry. I think we have to take that offline. Do we have any out-of-the-box PLM connectors? We don't have any out-of-the-box PLM connectors at this point. We work with a number of PLM vendors. Most notably, we work with PTC Windchill, and we have a strong project going on, a strategic project with ARUS. So in developing a standard out-of-the-box PLM connector. So those are the two primary PLM systems that we are working with. How's the relationship between the product model and its features and the customers and technical requirements? How's the relationship between the product model and its features and the customer and technical requirements? So the product model contains both technical and commercial aspects, and so part of the model will deal with the technical requirements and the technical features, and other parts will deal with the more commercial and customer requirements, and it's all tied together by rules. Those rules are quite the same. They look the same, and they are expressed the same way. How is ACE capable of connecting with requirements? That's an excellent question, and and the way we normally deal with the requirement management in Doors, for example, is that we again use the feature codes as the link and share those as part of Doors. And there are some extensions to the requirement systems that allows you to get a full traceability from the requirements to the rules that gets put into the in the configuration system. Okay, we are running out of time. There's still a lot of questions. We will try to collect these and get them back to you. Let's see, I can still try to answer a few here. One question is that they're using Teamcenter for product different application. How will it be integrated and replaced with ACE? I don't think I can answer that quickly. We have had a lot of collaboration actually with Teamcenter and UGS over the years, and there are some ways to do that, but I cannot answer that quickly. Other questions here? I think we need to try to wrap this up. There's actually a lot of questions. I'm sorry we're running out of time here. One question here is about typically these changes are not implemented at the same time across processes. A change might be effective at a certain date for engineering and another date for ordering. How do you usually handle change orchestration and implementation? That's an excellent question and certainly correct. The way we normally do that is that there's a separate, the effectivity date that we manage in the configuration system deals with the manufacturing date. But the time that information gets fed to other systems, so for example, an ordering system, that there's a whole release process that deals with that. It deals with selecting the data out of the based on the effectivity range. It picks the data and release it to the downstream system, and that release process is where you set up when that data becomes available. And that's how you orchestrate the availability of the data for downstream systems. Do you support rules and configurations between two different products? That's actually a very good question, because right now we don't do that in ACE. We don't have what we call system level configuration capabilities, but that is something we are building in as we speak. And that will come later this year, where we will have ability to define across product rules in our modeling environment, and that is of course an important feature. There's another question whether we have out-of-the-box CAD connectivity, and we do. We have a plugin for SolidWorks, and we are considering to extend that to other CAD systems where you can, because the point is that some rules really start in the geometric space, in the CAD space, and we do allow you to express those in SolidWorks in our plugin, and link those to those engineering rules, the CAD rules, link them to a commercial view in our ACE system. More details here. There's a lot of questions. I'm quite. I think there's many good questions here. It's a little hard to answer fully on these. One question is whether you get the slides after the recording. The recording certainly will be made available online, and the slides, well, they will be in the recording. I think we can also make those available. Let's see. That relates to another question, whether you can look at this webinar later. Yes, it will be available on our website, and you can just see it again as recorded. And then there's a question about whether you can define rules between different products, for example, a vehicle and a service. And yes, that will be possible. And being able to define services associated with the product is a very common thing that we do, service contracts and other types of services. So I think, and the very last question is whether we support the cloud application. And yes, we are offering cloud and SaaS solutions to the market. So with that, I think I just want to say thank you to everybody who have attended this, and I know we have again gone over time a little bit. I can just tell you to go to our website. There's more information there, and you can also click on this button here, and it will take you to a form, and you can get a more thorough demo, of course, of our software, and a much more timely walkthrough. So with that, I want to thank everybody and say thank you for now.